Good afternoon and welcome back to our first lab in Gns3. So like I said in the previous video, we'll just create this topology in Gns3, and that's what I've done here. So I've just labeled the links using, you just come here and you put whatever you want to label, so that we have a more intuitive topology, topological diagram. So I think I showed you how to cable all this. So what we'll do is, because I've not configured anything on these devices, we'll just come back to packet tracer, go to in the lab environment. I always like to remove the passwords, because like now you can see that mistyping them. Enable Cisco. But anyway, so we can type show run, because we don't want to do the same configurations that we have done on these routers. We do them afresh on Gns3. And this is actually how you would, let's say that you're upgrading the router in your network, or the routers in your network, a switch have blown up, or you want to replace it. Of course, you don't want to repeat all the configurations on the new device. Maybe you are just replacing it, and you have a limited outage window, so you don't want to cause a network outage that will take the whole day while your users are anxious to do whatever. So I'm just cleaning this thing instead of configuring it afresh. Of course, on the other devices we need to do no shut, and on my Gns3 it doesn't have gig interface, so I need to do F00. Should have just put F. Again, this is just because you can type the whole command or just a shortcut. F01, then we do no shutdown. These other ones are not there, they're not relevant. You don't need the clock rate in Gns3. Can do no shut. And also my interfaces are serial 00, serial 01. You just clean up your whatever, so we can remove all this, because otherwise when you paste them on the other device they'll give us errors. For the RAP I can also remove it, so that we do a review together. And also the default route, this might actually confuse us. Let me remove all this. I'll actually remove even up to the banner, but in your case you can leave it. So, and I can actually do no login, so that I don't want to in fact, let me remove these passwords, because on my Gns3 I don't want to have all this, all those configurations. Alright, so when we have that, in fact I can even remove in my case I'll remove all this, because I don't want the passwords to be there. And maybe it would have been easier to just go to the device. Now that I have removed a lot of stuff, maybe it would have been easier to just go to router 1. I have already consoled to my devices, so maybe it would have been easier for me to just come here and do the configurations without pasting them like that. But anyway, you can see how easy it can be, and I just do and I have pasted them on the wrong router. I've done it on router 3, and I've actually saved because damn, I should have just done a reload so that I remove the bad configurations that I've done on my device. So anyway, all I need to do is just go to, so first of all let me paste this in the right device, because I've messed up my topology. I need to be on router 1 with global config mode. Router 1, so I need to go back to my packet tracer, get router 3, CLI, log into it, enable show run, all the way up to the end. You copy up to the host name. Another notepad for router 3, and just clean it up. I don't think I need anything up to on my devices. It has a base configuration so that I can remove all those. Here I'll just need to do no shut, and this is F. Can remove all this other stuff, we don't need it. I'll put an exclamation mark. After this, let me put no shut. Can it even remove the RIP like I did on the other one, so that we have a more, and for the serial interfaces, this one needs to be serial 01. I don't need to do IP flow, and I think I can, in my case I can remove all the rest. So it's just some 2 IP addresses that I could have just easily configured on my devices, but I'm showing you how to do it, especially in the real world, because the configurations might be a lot. So now I can save on that one for real, and WR, come to router 2. Now we are on router 2, so I need to come back to my packet tracer, CLI, and Cisco show run. I don't need to copy all the way to, in fact I can just leave all this other stuff that I just copy from here all the way to the host name. Copy, come to R2. I don't need the passwords because like I've said, in the lab environment, sometimes you don't want those hurdles of typing the passwords every time you want to come back to your topology. No shutdown. I need all this. Then we do no shutdown. Now this one needs to be F00, F00, and this is S00. Because the modular routers that we have used in my Gns3 don't have those 3 zeros, yeah, 0000. Again, I think I've explained that in the previous video. So where is my Gns3? No, I need the console. I'm on router 2, so global config mode, paste. So I think I've configured all the routers, so I can start from router 1 and type show IP interface brief to see whether my interfaces are up. I think I did not clean this one, eh? That one is going where, and why is it up? Am I on F41? So F01, I think I'll remove this IP address, but for now let's we can type show Cdp Neighbors so that we see what we are connected to. 001.60 001. Why am I seeing R1? Yeah, I think it's because router 3 we changed we had configured it as R1. So my router 1, the router that I'm in right now, router 1 here, is still saying you know, the entry here have not yet timed out. Yeah, it has this hold time. I don't know what's the maximum by default. So if you continue show Cdp Neighbors, I think it is actually timing out. You can see here it was 36. So actually the whole time is what? I don't know, maybe you can calculate from there. There it is gone. So router 1, it can see that we are connected to router 2 and router 3. So router 2 on 0000, and that's exactly what we have. Router 2 on S00. So we can just try to ping the other side. 192.168. What do we have? .1.66. .1.66. We can ping it. We can even try to telnet to it to make sure that we're actually going to router 2. So you can see, because I've removed passwords, I don't want the passwords, I can easily telnet back and forth without the hurdles of typing passwords in the lab environment. So I think I now have what we have in, or what we had in Packet Tracer. So we can just move on. Well, apart from the PCs, and this is where we are using virtual PCs. To put this in the previous video, this is where I showed you come here to the hosts. You can use these VPCs. You can use this host if you want to use, say, your PC as one of the devices. We'll actually put the cloud to connect to the internet. Yeah, so that you can simulate the internet. In fact, you can do that. And I don't know why on my device I have lost internet. Now on my real laptop, maybe my internet have gone down. Let me try to I'm now digressing to troubleshoot my internet connection. Maybe a small router here at home have frozen. So anyway, let's we will add the internet data. This one we can call the cloud as the internet or the ISP. Yeah, we will connect to that later. So for the virtual PCs, once you put them there and you boot them, you also console to them, but unlike packet tracer, it's just a command line that we can use to do the pings, traceat, and all that. You can see it's a virtual PC simulator. This is actually a simulator, not for the virtual PCs. Yeah, for the virtual PCs, this is a simulator, not an emulator. So we can type show to see the IP addresses that are configured on my whatever. So if there is no IP, you say IP. Do we put add? I've forgotten how we add IP addresses, but we are on PC1. We do 192.168.1.30, the last usable IP address in our subnet, because we are in PC1.30. Now you put the default gateway IP address, which is 192.0.1. For the subnet mask, no, it's a /27. Hit enter. Not in the same subnet. Okay, what do you mean not in the same subnet? I think that's how we put the gateway, but actually you can put it here, 27 192.168.1. My bad. Actually using .0. I mistyped things here. I'm using I'm remembering the IP address of my home router here. Yeah, because I was wondering how do you assign. So we can see PC1 have an IP address of that 224, the default, because my VPC, VPC software can be able to convert from slash notation to decimal notation. So you see where you're subnetting skills are coming in. So of course, to verify, we need to do 192.168.1.1, and you can see that we can reach. Again, this is just a simulation software. It's simulating a PC command prompt. So we can actually reach router 1. So I'll just assign the IP addresses of the other PCs. Go to PC2, we say IP 192.168.1.62, where the gateway is .63. So 62.192.168.1.33 is still a /27. Checking for duplicate address and all that. You can try to ping the default gateway. Not reachable. What did he do? So we can go to, I'm on PC2. Am I assigning it the right IP address? Where is it? Yeah. I'm actually assigning the wrong IP, but anyway, to assign it again, it will just overwrite. So we need to be on this. This is the one that needs this IP address here. So I'll just copy. paste it there. So for PC2 this is where you need to change the IP addresses. Like the default gateway is .97, where this one have an IP address of 125, the last usable IP address in that subnet. Enter. As that one is checking, we can try to ping the gateway. So we do ping. So from PC3 we can reach router 2. I think I put these PCs in a way that is a bit counterintuitive. So PC2 should have been the one connected to router 2. But anyway, so long as we have the topology here, we can be able to follow and all that. So that one can reach its gateway, and this one also, can we reach the gateway? .97. Yes, we can reach the gateway and all that. But we know that we cannot have end-to-end connectivity because we have not configured the routing protocol. I removed it so that we can review what we already know by now. So by now I hope that we all can be able to do base configurations, configure RIP, disable auto summary, and I think I touched on these two in the previous video, but or in the previous videos, but anyway, let's just review, because configuring RIP is pretty easy. Where is that? So let me get back to configure RIP. You just go to, and I think we are now all gurus when it comes to now configuring RIP and all that. So you just take the directly connected networks, or the networks that this router here knows about. So you go to router RIP. I said you do version 2, no auto summary, and with RIP you type the networks in their classful manner. So with RIP you don't have granularity, granularity in that you can't select the networks that you want to advertise, because like let's say HQ had some subnets within the 192.168.1 network that you wanted them not to be advertised to the rest of the network. With RIP you don't have those options, but anyway, I think we'll appreciate that fact when we look at the other routing protocols. So no auto summary. I said you have to type these networks in their classful manner, 172.16.0.0. So even if we have a subnet here, because if you look at what we configured on loopback interface back in our packet tracer, it's not a /16. So even if you type it .1, I think it was a /24 what you configured. Now if you say do show run, and I love Gns3 because now we can do all the shortcuts that can work on the real device will work on Gns3. So you can see that when I type do show run section router, just so that I don't see the whole running config, just specifically to go. So you can see we have typed it as a classless or CIDR manner, and you can see that it has summarized back to class B, to the default whatever. So in the exam environment you're supposed to type it like this. If you type it like this, it will deduct marks. You're supposed to type them in their classful manner. So, and just like that, we have catered for all the networks apart from this one will remove it. We have catered for all the networks in known to router 1. And actually now with Gns3, of course, we can be able to do packet Wireshark capture. In fact, we can do that so that we see the communication as it is happening, the type of packets that are being sent between these two. So you can see you have some, remind me later, you have some RIP version 2 updates. You see RIP is quite a slow routing protocol, because you can see it sends an update once every 30 seconds. Yeah. And if you are on packet tracer or on the real equipment, because you don't have that handy shortcut of using Wireshark to capture your packets, you can just come here and do debug IP RIP PRIP. Debug lets you see events happening real time on your device, and you can see that RIP is quite a slow protocol. There we go. So it is sending updates. So every 30 seconds is like it's flooding the whole routing table to the neighbors. Yeah. And you need to be careful with debugs, especially on or in production network, because they can eat, it's a high priority CPU interrupt. Yeah, it's like the task manager. You know that the task manager is a high priority CPU, but also it depends with what you're debugging. Although in a production environment, if it was a real network, this stuff would be a lot. So you don't want to leave them on for long, because they'll anyway, it's just a troubleshooting tool. Another thing that you can debug is debug IP routing, to see routes as they are injected into the routing table. So right now my router 1 is a lone ranger. I have no neighbors to talk to, because we have not turned on the daemons on the other routers, so we need to do that. If we say do show IP interface brief, this one only knows about the 192 network, so we can do router RIP version 2. We just do one network statement will be enough. .1.0. Now we can come back to here and see the updates, and maybe I need to undebug. To turn off a debug, you say no debug IP RIP, because I want us to analyze these messages a bit, because debugs, like I've said, is a handy tool that you can use to see what is happening real time on your device. Flash null. So anyway, here we're just seeing what RIP is doing. The RIP daemon, is just taking routes in the routing table and advertising it to the neighbors, putting a metric. Metric is the cost. And did we get a debug of IP routing? I think it is still running. Debug IP routing is on, because all I can see is just this. I think this one now, this output here was given by debug IP routing, showing us that routing table, it have learned about this network. The next top router is this one. So you can see the routing table is adding this network, which we have known via this, and it is RIP, the metric. So you can see the first this I said is the believability. of a route source. Yeah, and this is the metric. So my router 1 knows that for me to reach this network, it is one hop away or one router away. So we can just configure on the last one to review what you have done so far. Do show IP interface brief. So I actually need to int f01. We are having this because we had wrongly pasted the no IP add, the wrong configuration. Yeah, there are one configurations on router 3. You can even shut down that thing so that you have a cleaner output where we have the only networks that are known to this guy. We also have a loopback interface, so we can say no int lo0 loopback 1. Right now we can do router rip network 192.168.1.0, and we actually did not do no auto summary. Version 2. Did we do that on router 2? Version 2, no auto summary. Alright, so with that, I think we have achieved the whole routing table, and you can see because we have a debug running of IP routing, it lets you see as routes are added or deleted in the routing table. Yeah, RIP is quite a slow protocol because if you lose connection to say, you know, somebody trips on the cable that is connecting to the LAN there, if you go to router 2 and we cause a failure, we come to int f00, do a shutdown, hit enter, come back to router 1, you can see that have taken quite some time, of course depending with where the timer was after they sent the last update, and you can see that now that route is being deleted from the routing table. So this is where we are saying that routing distance vector routing protocols are prone to errors, to routing loops, or can be prone to that if you because you see the way it is a bit slow. Let's say if this guy had sent let's say if router 2 had sent an update just a second ago, yeah, and then it loses connection here, and for router 1, let's say it had sent its update like 28 seconds ago. So when this router 2 lost connection to its LAN, router 2 sent an update with the full routing table. There's a possibility that router 2 can point to router 1 as its source to reach this network, and that's why you now start having those routing loops and all that. But we said we have a few mechanisms that, anyway, I think I'm belaboring on the semantics. So I need to go to int f00 and do, if I can type, no shutdown to restore our network connectivity. So now I believe that our network have full convergence, or all the routers know about both the local networks and remote networks. To verify, of course, we can go to any of the routers and we type show IP routes to look at the routing table, and we have some RIP. Why do we have only one RIP root. This spells a bit of disaster. Did we not do something on one of these routers? Show IP routes. Interesting. Router 2, it have several router. Let's go to router 3. Show IP routes. Or maybe my RIP is taking time to update the routing table. Still I'm not getting those networks. What's the deal here? So I can get the .96 but not 32. Which network here did I do no shut? Let's type show IP interface brief. Yeah, I did not do a no shutdown on the. And how come the other routers have all these networks? Yeah, router 3, router 2, RIP. So anyway, let me just go to int f01, do a no shutdown. I'm actually doing on the wrong interface. So it's int f00, do a no shutdown. Now I have shown you how to turn off a debug, like one debug. Yeah, so this is where you say no debug IP routing. But suppose you have so many that are running, you can do u or undebug. That is undebug all. But you use a space, a shortcut of u all, yeah, meaning undebug all. So use space all. If I can type, but I think I have turned them off anyway. So we can try to ping. On PC1 I can do 192.168.1.125, which is one of the PCs that so you can see some ping packets were lost as you were doing the ARPing. I don't know whether ARP-A is supported or is it show up, as we are doing some ARP and all that. It expires in 93 seconds. But anyway, I was trying to demonstrate that some of the ping packets were lost because you see you are trying to ping from PC1 up to PC whatever. Now if I do the second ping, you can see that we have 100% success rate, and if I try to ping the other one is what, 62. We expect to lose a few pings. We can even do a trace. What does, I think it's 192.168.1.62. Yeah, we can see how we are getting there. So you can see from PC1 we are going to the default gateway .66, and then we are there. So we can see how we are going. So anyway, I think all that we have just belabored on this. Now to disable updates on unnecessary interfaces, or what I mean by that is disable unnecessary updates on appropriate interfaces is you see there's no point of sending updates out F00. Yeah, And for RIP, there's no way you can remove that, because as in using the network statement. So what we need to do is configure these interfaces as passive. That way they don't send those RIP updates. And so I think from the Wireshark we can see a lot of all that activities. So I'm saying when we start the capture here, why are we not having any activity? To test, we can try to ping, can even do a trace 2.62. Yes, we can see some ICMP stuff that, so it is actually capturing. So the point here is we are sending these RIP updates on the F00 interface every 30 seconds. First of all, we are wasting the bandwidth and wasting the network resources, and it can also be a security risk. So what we need to do is come to the devices, we go to router, we do it under router configuration mode. So we say router RIP, so we say passive interface, we can say F00. So you do that for all the interfaces that you have on a device. So like let's go to router 2, we'll say router RIP. Another way we can do is passive interface default. That makes every interface not to participate in essentially we have killed the routing protocol if you do that. So this is where by default you have made every interface passive. Now you negate the ones that you don't want. So you say no passive interface S00. Yeah. That way I'm saying, of course, is far much easier to, like if let's say router 2 had a lot of other interfaces, VLANs and all that, you know, going one by one is a bit more tedious than going through that shortcut. Yeah. So, and I don't know now whether my Wireshark will stop. If you can wait here, I don't expect it to be sending RIP updates out F00. So that's what we mean by making the interfaces passive. Now we talked about you propagate the default route. Now this is where we need to when we have the internet connection, which if I come here to my cloud and configure, this is where under Ethernet you can choose you know, Gns3 have this cool feature of allowing you to connect your virtual topology to the real network. Yeah, so this internet, this cloud, and here this is where I'm choosing the NICs. Yeah, the NICs of my laptop. If you come to open network and sharing, so this is where I'm choosing one of any of my NICs here, so that I can connect this virtual topology to the real network. So here you just choose whichever NIC and you add. Okay, now I can just take a cable and connect to that Wi-Fi NIC, take it to F01. All I need to do now is go to F01 and configure it with the right IP address. Interface F01 IP add. The IP addresses that I use in my small LAN here at home is 192.168.0.0/24. So this guy, we can give him I don't know which IP addresses are in use. IP config, like my laptop here is using .10, so maybe let me just assign this .254. I don't think there is any device here that is using that IP address in my network. So .0 int f01 and do a no shutdown. So to verify, I can try to ping my default gateway, and now this is my real default gateway of and I can't reach it. Let me remotely log into my desktop and see whether I can reach this virtual, whatever. So the .254. Why is it so slow? I don't know whether I've lost connection to it. But to test, I can show IP root. .0, do you have anything? .0 show IP interface brief. It's up. Let me try to ping it from my PC here. Ping 192.168.0.254. Maybe it's a Wi-Fi issue that try to ping it from here. 192.168.0.254. Yeah, we can't access it from but anyway, I wanted us to see how we propagate that default route, although I think we saw it in the previous videos. Looking at the time, I think let's stop there. We will continue from there once I troubleshoot and figure out what's the problem. So with that, I hope this has been informative to you. I'd like to thank you for viewing.